Hi, good day. This is grade 8 maths, and we're going to do the Pythagoras theorem. Right. So when you do or hear about the Pythagoras theorem, then one thing we need to know, there should be an angle of 90 degrees. So just as a reminder, if you have a thing that looks like a block, that actually means that angle is 90 degrees. So 90 degrees and Pythagoras theorem always go together. So just keep that in mind. Then a rule for the Pythagoras theorem is you have the three sides. If one of the sides are 90, then the opposite side of the 90 is what they call a hypotenuse side. So that will always look like this, almost like a diagonal. In Afrikaans, we say skynsy. So just the look and feel of this, you have two sides, side A, and then another side, side B. The opposite side I spoke about, which is C, and there must always be a 90 degrees. If there's not 90 degrees, it means it is not, you can't use the Pythagoras theorem. If you have all of that, then this rule over here is what we can apply. That means this side, A squared, plus this square to the bottom, B squared, equals C squared. Now, it doesn't matter how you write it. What is important is that the hypotenuse side must always be equal to stand on its own. So here I've noted as C. So the hypotenuse must always stand on its own. It doesn't matter what it is. So we'll do a couple of examples just to make that clear. So just keep this page in mind as we go along. All right, let's do example 1. So here you have this diagram. And what's important in this diagram is this is 90 degrees. So it's 90 degrees. So now you know we can use the Pythagoras theorem. So like the other formula said, it said we can take this over here and say x squared equal, let's use this one, 3 squared plus that one, 4 squared. So that's a rule of Pythagoras. So just keep in mind, let's just go back to the sum. The hypotenuse, this one over here, C stand on its own. Then it's just the other two, A squared plus B squared. So that is what we've done here. We just said, I like to keep the unknown variable on the left-hand side. You can put it on the right-hand side, but I just like it on the left. So there we have the x squared equals the 3 squared plus the 4 squared. And now you can just do the basic maths. 3 squared is 9. 4 squared is 16. If you add that up is 25. So you get x squared is 25. And then x will be square root of 25, which will equal 5. So that 5 will be here. That belongs there. So that is 5 centimeters. Just another thing I didn't note it earlier. They will always give the measurement as well. So in this case is centimeters. So always make sure if you do the sum that it always have the same measurement for all the sides. In this case is centimeters, all three sides. That's why the answer is 5 centimeters. Let's go to number 2. Now just another thing, I drew this shape differently. The other shapes will all look like that. The only thing you must keep in mind is where is this 90 degrees? Because the side opposite the 90 degrees, that will be the hypotenuse. So just look at where's the 90. So here's the 90. And so that 13 will be the hypotenuse. So that's the only thing you must remember. It doesn't matter how this triangle can look like that. That's 90. It can look like that. That's 90. It can be totally upside down that way. It doesn't matter how it looks. Only thing is, where's the 90? And then you know opposite the 90, that's the hypotenuse. That's the only thing you need to know. All right. So let's come to our sum again. So So remember, the hypotenuse is always the one that is equal to the others. And so I like to always start with the unknown variable first. So in this case, the unknown variable is the x. So I'm going to write x squared plus the 5 squared equals 13. It's not 1 and 3 squared, is a whole 13 squared. So let's just keep that in brackets for now. So just again, a reminder, here's the 90 degrees. So the one opposite, that's the hypotenuse. So that's always the one that will stand on its own. And then it's just the other two, the 5 squared plus the x squared. Like I say, it doesn't matter how you write it. I always start with the x, try to keep it on the left, and then I just follow the logic. This x squared plus the 5 squared equals 13 squared. All right, so now it's just a simple maths just to do it. So x squared, leave that for now. 5 squared, that's 5 times 5 is 25. 13 squared, 13 times 13 is 169. Keep the x squared over here. Take the 25 to the right-hand side. There's one of my other videos you can watch about integers. There I explain all these kind of things, how I move things from the left to the right and how to solve for x. You can go through all of that videos if you haven't yet. So x squared is 144. That means x is square root of 144. It gives us x equal 12. And that x equals 12 is what we're going to need to write there. So this angle now becomes 12 centimeters. Sorry, not the angle, the side. So the side is 12 centimeters. Another way to check, if you finish, is maybe you can just say this 5 squared plus 12 squared and see if you get 13 squared. Just a way for you to check. So let's just check 5 squared plus 12 squared. What do you get? That is 25 plus 144 is 169. And 169 is equal to 13 squared. Then you know you are correct. Do another example. So this one, that's the first thing you do. You look where's the 90 degrees or where's the hypotenuse. So there's the 90, there's the hypotenuse. So this green one is the one that always stands on its own, equals 20. Oh, but look, now is meters squared. So just keep this in mind if we write the answer later. So that's meters. That's meters. So that's 20. Keep it in a bracket, all of that squared. And now it's going to be x squared plus 12 squared. So just again, recap, x squared plus 12 squared equals 20 squared. And now you just work out the sum. X squared plus 12 squared is 144. 20 squared is 20 times 20. That is, what's that, 400. Then x squared equals the 400 minus the 144. 400 minus 144, it's 256. So x squared is 256. So x is square root of 256. That gives x equal to 16. And the 16 over here is now not centimeters like the previous sum, but that is meters. Because like I mentioned, everything is meters. So this side over here is 16 meters. That is the basic. And if you want to check, you can just check again. 12 squared plus 12 squared plus 16 squared, and just see if you can get 20 squared. That's the basics. One triangle, all the sums we did is the same. One triangle, one thing of 90 degrees. But in the exam, they might give you something like this. That just looks a bit different. So here is just a big sum, a big triangle, A, B, C, and then some smaller ones. Then they give the two sides over here. And you need to determine this x over here. Now, if you have a sum like this, what is important now to do is just to understand the approach we're going to take. See what we have and see what we need. So we need this side over here. But like I mentioned, to have us get one side, if you look at our previous sums, you need at least two other sides and the 90 degrees. So you need, for this kind of stuff, you need the 90. The 90 is to use the Pythagoras theorem. And then you need two sides. Now in our sum here, you have x, but we don't have the other two sides. So we need these two. So just keep in mind, they are the same, because this lines over here means they are the same. So if we can find one of these two, AD or BD, so we can find either that one or that one, then at least we know we are, the other one will be exactly the same. But let's see what we have here. I'm going to draw this triangle in red, triangle ADC, to see if you can see that. So this triangle I'm going to draw in red. So let's focus on this one first, the red triangle. Here's the 90, so we can use that. And now, if you look properly, we have a 13, we have two sides, and we need that side over there. And just look, if we can get this side, and then this BD is the same as AD, then we have the two sides for this triangle, and then we can find X. So that is going to be my approach. First, work with the red triangle to find that side over there. And now it's just Pythagoras. Because now, just look, I'm gonna write, that's AD. So I'm gonna write AD squared plus, just gonna write everything out first, plus DC squared equals AC squared. I'm just writing this in the letters so that you can just understand. So this side is AD, this one at the bottom is DC, and the hypotenuse is AC. So I'm just, and just a reminder, the side opposite the 90 degrees, that's the hypotenuse. Now you can just fill it in. We don't have AD yet. So let's keep AD like that. DC is this one here at the bottom. That's 12 centimeters. So that's 12 squared equals AC, which is this one over here. That's 13 centimeters. We can just write 13 squared. So everything is in centimeters, so we know the final answer will also be in centimeters. All right, so we have AD squared plus 12 squared is 144 equal 13 squared is 169. Then you have AD squared equals 169 minus 144. That answer gives you 25. So AD squared equals 25. So AD is square root of 25. And you know this by now, square root of 25 is 5. So that's AD, which is 5 centimeters. So now it just remove a couple of things here. And then I'm going to write AD, that is 5 centimeters. Okay, so now the red triangle is complete. So let's work with, let's remove this blue here. Then I'm going to make this green. So now we work with the green triangle. Triangle ABD. But AD is 5 centimeters. And remember, this two signs over here mean the sides are the same. So that means BD is also 5 centimeters. And keep in mind, we have this 90. That means X is the hypotenuse. And now we can use Pythagoras again, which say, and I'm going to start with X squared equal, and I'm just going to write the 5 squared plus 5 squared. So there's the X squared. Then I'm using this one here, 5 squared plus that 5 squared. Now let's just complete the sum. That's 25 plus 25. That's 50. So x squared is 50. So x is just square root 50. We can, if you want to, simplify and say square root of 50 is 7.07. It depends what the teacher wants. So if they say the sum must be 2 decimal, then you make it 7, x is 7.07 centimeters. If they say they want only 1 decimal, then you need only this one here. The 7 is more than 5. So then it's going to be 7.1 centimeters. So it doesn't matter how you write it, or you could have just written square root 50. So it's just a matter of read the question carefully and just see how the answer must be. Right, let's do one last one. And look at this one. So now let's see what do they want. So they want length AE. This is what they want. Length AE. Let me try to draw it properly. So this is what they want, AE. But now we have to ask ourselves, let's just draw this separate. I'm going to draw it over here. Just this triangle. So we have this over here. Can you see the triangle? Oops. So there's your A, here's your E, there's your D, there's the 90, and that's 7. And almost like you have a thing here, but from that point to that point is 10 centimeters. So you can't, I'm talking about this point over here, but I just removed this for now. So from that dot to there's 10, but you can't do anything. This line is not complete. This AD is not complete. We need the AE, which is this here. But to get AE, you need 2 sides, and we only have the 7 and part of this one, 10. We don't even have this. So if you look at this one over here, there's AC. So if we can get AC, do you agree then we have this whole line over here? And if we have that line, that side, then we have this side and also this one here, and then we can work out AE. So let's see what we can do. Now they give us that this triangle, the red one, they say this is 90. So already, if you know something is 90, what must you remember? Pythagoras. So let's use the red triangle. Remember this one here, opposite the 90 is the hypotenuse. So I'm going to use a red triangle to first determine this AC over here. So we can write it down here at the bottom. I'm just going to write it here separate. I'm going to write AC squared equals the 9 squared plus the 12 squared. Let me just show what I've done. So I want this AC. So I just used Pythagoras and said AC squared equals the 9 squared plus the 12 squared. And now we work it out. 9 squared is 81. 12 squared is 144. 81 and 144 is 225. So AC squared equals 225. And that means AC on its own is equal to 15. So this AC is 15. So I'm going to write it now in here. That's 15 centimeters. And because I write it there, just remove all of this. I can actually, so this A, this is C, this point there. So this is all, this is now 15 centimeters. I'm just doing this part separate so that you can just see what I'm trying to do. So let's come to the left again. So we have AC, which is 15. We have CD, which is 10. Now we, in this left triangle, we need AE. So let's use a yellow color. Let's see if I can just use a yellow color, and I'm going to work now with this triangle, this one over here. I'm going to work with that, but just look here on the right hand side. I'm just going to do everything over here and just draw that triangle over there so that we can at least see what we're busy with. So now we have that. We need this AE over here. So we need this AE, and we have this part over here, 15 and 10. So 15 is from that point to here. And from CD, that is 10. And 15 plus 10 equals 25. So now I'm going to take all of this away. And I'm just going to say this side AD is equal to 25 centimeters. And now the sum looks much neater. Just the way I drew it is not 100% correct, but the 90 degrees is here. And just keep in mind, the one opposite the 90, that is always the hypotenuse. Therefore, AE squared plus the 7 squared equals a 25 squared. Can you see that? So there's the 90. So the one opposite the 90 stands alone. That's 25 squared. And now we're going to have AE squared plus 7 squared. So AE squared plus, that is going to be 49. 7 squared equals 25 times 25, which is 625. Just double check. 25 times 25 is 625. And if we take the 49 to the other side, then that answer is going to be 576. So AE is the square root of 576. That means AE alone is equal to 24. So this AE, that is 24, and that is centimeters, and just come back this side. So this AE is 24 centimeters. So I just want to explain quickly again what I did. So just the reason I'm doing this separately is to not confuse you with the ray triangle. So that's why I just drew this triangle separately. So we didn't have this 15. We only had the bottom part 10, but we drew the ray triangle here on top. And because this is 90 degrees, we could use Pythagoras, the Pythagoras theorem, to get to AC. At the end, this AC plus CD gave us this whole line here of 25. And we could use this 25 to Pythagoras again to get to this 24, which is the same as that 24. So like you say, before the time, it's just about our approach, what we must do. Before I finish, I just want to show you one tip that will just help you with your answers. So the tip is this. If you have the Pythagoras theorem and you have all your answers, the hypotenuse, the one opposite the 90, must always be more than the other two. So the one side is 3, that one is 4, and this one is 5. So it looks right. It is right, but I mean, it must always be more. So what I'm trying to say, if this answer was, for example, 3.5, then you know this is not correct, because the hypotenuse over here must always be more than the other two. So that's one thing to remember. Let's just look at our other sums. This one over here, we have the 5 and the 12, and the hypotenuse is 13. That's correct. Let's look at this one. We have the 12, and where's the 90? There's the 90. So the hypotenuse is 20. So I just got confused now because the triangle looked now different. But like I said, always look where's the 90, and that's your starting point, and the side opposite is the hypotenuse, and the hypotenuse must always be longer than the other two. So that's 20. The other two is 16 and 12. So that looks fine. Let's look at this one. So if we break the ray triangle, The hypotenuse is the 13, which is more than the 12 and the 5. And in the green triangle, the hypotenuse is a 7.07 or 7.1, which is more than the 5 and this 5 over here. So all of that looks correct. And in the last sum we did, in the red triangle, there's a 9 and 12. The hypotenuse is 15, which is more. That's right. And if we look at the bigger triangle here, remember, this is the 90. So this is the hypotenuse, 25. 25 is more than 24 and 7. So that is correct. So this is the Pythagoras theorem. Like I said at the beginning, the only thing to remember is the 90, and the one opposite the 90 is the hypotenuse, and this is your formula. You're going to use it a lot going forward. Therefore, you can come back anytime to this video and just to refresh yourself about the Pythagoras theorem. Thank you very much. Have a good day. Bye-bye.